It came on it. All right. They're pretty good. There's sour cream and like sea salt and vinegar or something. They're all good. Yeah. I know. Because I can't eat chips because that's got like 7,000 calories in it. But those are hollow, so they don't have any calories, right? You bite on it, it's air. But they're good. It's just enough of a crunch that it's kind of like eating chips, but not really like eating chips. So it's like chips without the calories. It is. Okay, here we go. So all of you have taken physics, right? Yes. Not everybody took physics? I thought you had to take physics. I thought everybody took physics their junior year. So not everybody takes physics anymore? Oh. Oh, we're doing it because it's the easy part. It's okay. So that's what I was going to tell you. You've all done this in physics, and so it's easy though. This is the easy part, okay? So we're going to like this. And so the reason we're doing this, and the reason we do it right now, is because it is easy, and we're just going to do this right into spring break, like easy all the way to spring break, okay? 1 week. 1 week, friends, 1 week. Okay. So, I'm going to start with some vocabulary, and then we're going to do some drawing, and then we'll be done. Okay. So, vector has two attributes. It has magnitude and amplitude. The magnitude is the length, and the amplitude is the direction. And the magnitude is sometimes called the norm. And we use this symbol for it. It's the norm. I just told you. So it's like two little lines, the V with the vector symbol, and two more lines. A geometric vector is a representation of a vector as a directed line segment. And a vector, first of all, uses that little symbol right there, and it goes P to Q. I hope so. Okay, P to Q. So this is the initial point, and this is the terminal point. This is also, so this is, since it's like where the arrow part is, it's the head, and this is the tail. So equivalent vectors are congruent. They have the same two attributes, which are magnitude and amplitude. So they have the same length and direction. Parallel vectors have the same or opposite direction. So parallel vectors are just like parallel lines. They can either go the same direction or they can like opposite and not touch. Opposite vectors have the same magnitude and opposite amplitude or direction. A unit vector has a magnitude of 1. And the unit vector is written I plus j. Okay, so the I is the unit on x and j is the unit on y. Okay? So this I would write 3i plus 2j. It's just the way it's written for the unit vector. So the unit vector has a magnitude of 1, just like the unit circle has a radius of 1. Okay? So the scalar is a non-zero multiplier. Scalar product means scalar multiplication. So if I have W, 2W, 2 is the scalar, and I just multiplied 2 times W. Or I can add together 2 W's, one or the other. So there's 2 ways to do this. The geometric way, which we're going to do today, and the algebraic way, which we'll do next week. We're going to draw on all of them. The component vectors are vectors that are added. So when we're drawing, this is what it's going to look like. If I draw this, and this is A, and if I draw this and it's B. So this is vector A and vector B. If I want to add them together, A plus B. So there's 2 ways to do it. There's the triangle method and the parallelogram method. So the triangle method, you're going to draw A, and then you're going to take the initial point of B and put it on the terminal point of A. So this is going to connect right here. So if I do that, if I draw A, and then I draw B, to get A plus B, I'm going to draw from the initial to the terminal, and this is A plus B. Pretty much. So we draw the resultant. Yeah. So this was initial to terminal, okay? So the parallelogram, you're going to put the 2 initial points together. So if I have this, if I have X and Y, so this time, look, I'm going to take this initial point and this initial point, and they're going to connect. The initial points. So if this is X, and I connect the initial point of Y, it looks like this. Because that's the vector symbol. This is a vector. And so now what I'm going to do is I'm going to put another Y right over here, exactly the same. And the X on this side. So look, the initials are together and now the terminals are together. Does everybody see that? Initials together, terminals together. And the way I get the resultant is I draw from the initial to the terminal. So this is x plus y. Well, I'm going to show you. So vector subtraction, to subtract a vector, we're going to add the opposite of the vector. Add the opposite. And orthogonal vectors are vectors that are perpendicular. Okay, so go to the white sheet. And I want to start on this side. Okay, so first of all, if I look at A, how far to get from the initial to the terminal did I go in the x direction? X, 2. So this one is 2. And how far did I go in the y direction? But which is it? Negative 3, right? From that point, I went down 3. What? A comma and a minus sign? Okay, these are for vectors. Because we have to identify them different than an ordered pair. So B. How far did it move in the x direction? 0. 0. So that's 0. And how far did it go down? 3. So minus 3. Yes. So C, 2 and 2. And D? 4, 1. Okay. So if I wanted to write this with the unit vector, this would be 2I minus 3j. This would be just minus 3j. 2I plus 2I. This would be 4I. Oh, j. That's what I wrote right there, j. And 4I plus j. Thank you. No. Okay, not a lot. Couple things, almost done. So, if I wanted to do 2 times A, I'm going to do 2 times A. So first of all, if I'm taking 2 times A, so here is this vector. So if I start here, I'm going to go over 2 and down 3. So this is A, but I need 2 of these, right? Well, it's 2 and negative 3. It's the same one. So what do I do next to get 2 times this? So let's draw it first of all, okay? So to draw it, I'm going to go over 2 and down 3. Now I have 2 of them. So now let's do what Isaac said. We're going to multiply 2 times the 2 and the negative 3. And when I do that, you have to multiply both things times the 2. So I get 4 and negative 6. if I'm going to write that, it'd be 4i minus 6j, if I write that. But the 4 and negative 6, if I start here, if I count over 4, 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6. You get the right answer. So, right. So, it's not very practical to draw all the time, is it? So that's why we'll do algebraic next week, okay? This is algebraic, and we'll do this, okay? All right, I want to do a triangle one now. Yes, we are. We're going to add C and D. We're going to add C and D. So these right here, that's why we have the paper. You have the paper. You can see the C and D, okay? All right. So the first thing I'm going to do is draw C. And I'm going to do the triangle method. So this is going to be initial to terminal, initial, terminal. And then draw the resultant. So let's start with C. If I put C right here, if I go up 2 and over 2, there's my C. Now D, what am I doing? I'm going to go over 4, 1, 2, 3, 4, and up 1. What do you mean why? That's for the parallelogram method. For the triangle, it's initial, terminal, initial, terminal. So we'll look on your notes that we just wrote. What does it say for triangle? Place the initial point of the second vector at the terminal point. Oh, yeah. Oh, yeah. So this right here is C plus D. That is the resultant. So my triangle, C plus D, was 1, 2, 3, 4, 5, 6. 1, 2, 3. So I think it should be 6, 3. So if I do it algebraically, if I have 2, 2 plus 4, 1, 2 plus 4 is 6, 2 plus 1 is 3, and I'm right. So you just add the x's and the y's algebraically. So this would be 6i plus 3j. Okay, so let's do one the parallelogram way. We'll do A plus D. A plus D. Okay, read on your notes. How do you do the parallelogram? Where do you start? You start with initial and initial. The two initials go together. Of course, yeah. So, if I start with A, so if I start here, I go over 2 and down 3. Here's my A. Here's my D. I'm going to go over 4 and up 1. So initial to initial. So I had A and D. Now what do I do?
And I do the A on that side.
I have to do the A on this side, right?
Yes.
Go down. So from this point now, I have to do A, which is over 2 and down 3. So this is A. And so the next one's easy because we don't have to count. We just connect. So this one's D. And where do I get the resultant, friends? Right. Initial to terminal. So this is A plus D. So I went over 1, 2, 3, 4, 5, 6. It looks like 6. Sorry. Not sorry. Minus 2. So now let's look at 2, negative 3, plus 4, 1. I ended up with 6, negative 2, and they match. So we did it right. So this would be 6i plus 2j.
Oh, so that's just to check your answer too, right?
Mm-hmm. But we're, yes, you're going to have to do both of these on a test, but yes. Yes, it's going to be so easy, everybody better get 100 on it. Everybody's getting 100. Shh, what? Because negative 3 plus 1 is negative 2. Oh, sorry, it's negative. There, it's right there. It's negative. Thank you. Good catch.
So can we just write 6i minus 2j?
Yes. Well, if I would have done it right, that's what we would have written. You can write it either way. But this is the way I would write it if I wouldn't have left it out. Okay. So here's what you're going to do.